We know there are thousands of species of ectomycorrhizal fungi. There's about 15,000. And even if you went out and sampled the roots of one large tree, there'd be more than 200 different species of these fungi on their fine little root tips. And so fundamentally, we're trying to figure out what they're all doing out there. Does a tree need all of those fungi to help it take up nutrients? Or are they there just because they could get there? We mostly work on experiments and questions that have to do with silviculture and how our forests are managed, because these fungi are found on tree roots. So I'll go get them and then you can see what they look like. We're trying to figure out what happens when you clear cut. Are the fungi still alive there so that when we plant new seedlings that they'll be able to associate with these fungi? Or if you plant mixtures of trees, is that better or worse? Lately, we've been working on a project where basically there is some long-term fertilization of forests that's going on to try to figure out if we can speed up the growth, especially of pine trees, because, of course, so many of them have died as a result of the pine beetle. We wanted to check and make sure that there was no detrimental effect on the ectomycorrhizal fungi, that they were still functioning the way that they should, and we found they were. There's a Gary Larson Far Side cartoon that I think really epitomizes the image that soil scientists have of the soil. And there's a picture of a snorkeler who's face down in his garden with the snorkel coming out the back of his head. And he says to his buddy, "Hey, Joe, I see that rake that we lost 2 years ago." But the idea is, of course, that you can't see into the soil. And that's the whole challenge of working in the soil. You can't sample it and take it back to the lab and put it under a microscope without disturbing it in some way. And that's especially important for these mycorrhizal fungi, because the whole way that they benefit plants is by having these delicate little thread-like cells that extend several centimeters or meters away from the plant root. So a lot of what we tend to do in my lab is to try to go out into the field and measure some of these physiological processes out there in situ. One of the things that brings me a lot of pleasure is I sing in a community choir. We have a fabulous director in Leroy Weems. One of the things Leroy tells us is that we need to listen to the people around us. When you're in a section, the sopranos or the altos or the tenors or the basses, you need to be singing with a unified sound. And so it's really important not just to focus on yourself, but to hear the other people around you. And when you're doing science, there are some parallels from the point of view of when you're running an experiment. You usually have a hypothesis about what is going to happen. But you have to really be willing to think of other possibilities, have your ears open, your mind open to other interpretations of your data. And so I really see that similarity in that when we're singing, we're trying to hear ourselves, but also hear other people around us. And I think when you're doing science, it's similar. You need to think about other people's ideas and other interpretations other than the ones that you have.